Hey everybody, welcome to Cassandra Lunch number 65. Amazing that we've made it this far. Today's topic is going to be on predicate pushdown inside the Spark Cassandra Connector. And if you don't know what that is, Obi is going to talk to you about it. And specifically with Cassandra, why that's very important to know how it works. And as Cassandra improves with, maybe in the future, better indexes. And then obviously with data stacks, we have the Solar Index. How can that be helpful for us when we're doing Spark processing? I'm one of the co-organizers. Josh and Arpan do a great job of making sure this thing is produced and the content gets up there and the blog posts are getting up there, as well as the videos. So thanks guys for your work. We're always looking for sponsors and speakers, and anybody that wants to help organize can reach out. We're part of a much bigger community called Data Community DC. As you can see, many different groups, and actually in a moment I'll show that there's a Data Week DC coming up. What do we cover here? We cover anything related to Cassandra, Cassandra protocol. We've yet to have some talks on Cosmos or Scala or UUID. Or managed key spaces for Cassandra, which are variants on Cassandra. But if anybody wants to do a little bit of research and show off, that'd be great. I don't see anybody new to this group, so I'm going to continue forward. Group rules, if you have questions, just ask it. Our company is one of the sponsors. We work on global data platforms with Cassandra, Spark, and Kafka. We are partnered with DataStax. They're a sponsor of the group as well. GW gives us great partnership from a visibility perspective as well. Bunch of sponsors locally and also organizationally. Is there anybody that has any, I know we have some announcements, so any new things coming up if you want to announce? Okay, well, as of I think yesterday, there's a bunch of events on the Data Week DC calendar. You can go to dataweekdc.com. We also have a couple of events coming up. Next one, this is probably supposed to be 66. And that one will be on dbeaver. And on September 21st and the following Tuesday, I will be giving a talk on how to migrate to the cloud. I'm waiting on a few things from DataStax, but we'll add it to the event page here momentarily. And with that, I'm going to go ahead and give you all our own announcements, which is we're always hiring data platform operators, engineers, and architects. As I mentioned, there's some events coming up in the next few weeks. Interested in this Apache Connector talk. That would be great. You can always find our videos on Cassandra Lunch on YouTube. So if you haven't already, subscribe. And if you're watching this on YouTube, subscribe. We're actually going to be eventually, I don't know how soon, but we're going to be moving our broadcast platform away from Zoom and to go directly to YouTube soon. So if you're subscribed, you'll get notifications on when the events are happening. And of course, you can always check out Cassandra.Link, which is the world's most authoritative knowledge base on all things Cassandra outside of DataStax. And I put that caveat in there because DataStax has a lot of good documentation about how to run Cassandra, especially DataStax, but there's a lot of other knowledge out there. So we organize it and we curate it for your benefit. And with that, I'll hand it over to Obi. The floor is yours.
All right, great. Let me share my screen. All right, so as you heard, my name is Obi Anant. Worked here at Anant for, I think we're coming up on 2 years. And I'm a data engineer here. Today our topic is, well, Spark predicate pushdown specifically to do with the Spark Cassandra connector, because this was actually a requested topic last time we requested topics from viewers. Someone wanted to learn about predicate pushdown in Spark. And so I sort of picked a subsection of that that has specifically to do with Cassandra for Cassandra Lunch. During this presentation, I generally prefer to take questions in the chat. There will be stopping points during the presentation before we move into the demo that we can answer questions. But if you have something really urgent to say, feel free to just unmute and speak up. So let's get started. So first, generally, Spark SQL predicate pushdown. What is that? So Spark predicate pushdown or filter pushdown is a technique that Spark uses to optimize queries. There are a large number of these. Essentially, when you give Spark a query that builds a data frame, it will first come up with a plan just normally. And then it will see what optimizations it can apply so that Spark itself doesn't have to do all the work or doesn't have to load all the data or a number of different things that that might make your application slower. So in this case, Spark SQL pushdown applies to data in Cassandra. If you're using DSE or you're using the Spark Cassandra connector, it can connect to JDBC data sources directly. If you want to use the PostgreSQL driver or connect to Cassandra via the JDBC, you can probably do that. And it also does predicate pushdown for Parquet data sources. Like if you're reading a Parquet table from disk, it will optimize your query in the same sort of way. It happens when you're executing a statement where or filter operation on a newly loaded data set. So if you're going to an external data source and you're loading that data in and then adding on a where clause or a filter. And it also works if those conditions are added in a Spark SQL statement. And it makes those conditions part of the query that gets sent to the database directly in order to reduce the number of entries being retrieved. So a query with no predicate performs a full table scan and gives Spark all of the data. And then without predicate pushdown, every query would do that and then do whatever filter or where operations that you have added. And then there are also various rules for predicate pushdown when it happens. So in Cassandra specifically, partition key columns can be pushed down as long as they're all included in the filter and there's no more than one equivalence. You can use an in clause to specify more than one, but you can't use it onto like direct equivalence predicates. And then clustering key columns can be pushed down as long as only the last predicate in the filter can be a non-equivalence one. So if you're using greater than, less than, greater than, equal, etc. And then if there's more than one predicate for one of your clustering columns, they can't both be equivalents. And then just generally, the Spark Cassandra connector connects Spark to Cassandra. It has the ability to expose Cassandra tables, RDDs, as data sets or data frames. You can use it via reader objects or via Spark SQL statements. And it allows you to write data to Cassandra as well as read from it and execute CQL statements from inside Spark applications. All right, so predicate pushdown in the connector. Inside the connector, predicate pushdown follows those rules that were laid out previously. Where clauses and filter statements that follow those previously laid out rules are pushed down to be processed in Cassandra if possible. And that's a typo, not great. You can process queries that would be impossible in CQL using Spark SQL or using different combinations of filters and etc. on data frames. But it won't benefit from predicate pushdown. So you'll trigger a full table scan that will then be followed by filtering once the data has been loaded into Spark. And then predicate pushdown comes alongside other query optimizations like column filtering, things like that. Column filtering specifically will just only load in data for the column that you request. So if your select clause is only requesting a single column of the data from your table, Spark will optimize by having the underlying database, in this case Cassandra, give you back only that column rather than giving you back the entire thing and then filtering down to only that column. And then the images here, well, the left one is not actually about predicate pushdown in Cassandra. It's sort of about predicate pushdown in normal SQL statements, like in preparation for a join. But the text underneath here is sort of the same benefit we get by doing predicate pushdown in Spark SQL. And it says, the earlier we process selections, the less tuples we need to manipulate higher up in the tree. And you're getting the same sort of benefit there, where normally maybe you trigger a full table scan, load all the data into Spark, and then filter down. Instead, you only have to, you send that filter clause or that where clause down to the database, and then import only the data that you actually want to use into Spark. And especially because Spark is a lazy evaluation, Spark uses lazy evaluation, things like that aren't necessarily saved. So if you end up writing a query that loads a full table into Cassandra and then filters down to a small number of rows, the rest of them don't necessarily stick around. So you're not getting any benefit out of loading all of that data into Cassandra if you don't need to. And then the image on the right is a sort of example. I think this is actually like a Databricks example. But you have a table that you're querying, and then you have a filter condition. And normally what you would do is you would scan the table, and then you would filter. But with predicate pushdown, the filter condition gets pushed down to the database. You scan the table for only the data that you actually want, and then you can bypass the filter altogether and just move into your actual data manipulation pipeline. And then something that the Spark Cassandra connector also does is count pushdown. So queries where you don't want any of the column values back afterwards, like count, get converted into Cassandra count operations rather than being loaded into a data frame and then counted inside Spark. So you're only, instead of loading in the entire table or even like a single column where each row represents a row from the table, what you get back from Cassandra is a number, and that's a lot easier to load in. In old versions, I believe that's actually still supported, but the Spark Cassandra connector used to use a specific function called Cassandra count to do this. Before, if you typed in Spark SQL select or whatever, or use the connector to get some data, and then put a .count, the Spark function after it, it would load all the data into Spark and then count manually. Whereas Cassandra count would do this sort of push down thing that is now sort of standard in the optimization of your Spark queries, where the count function just gets pushed down to Cassandra regardless. And then we can also see a little bit more if we look at some of the documentation for the Spark Cassandra connector. They talk about TTL and write time functions, which they're part of the Cassandra Spark extensions. So you need to have the extensions added to your environment to actually use them. But you can get the write time of a column or the time to live of a column, which would normally be like Cassandra specific, and Spark wouldn't be able to calculate them by getting data from Cassandra. Instead, if you include them in your Spark SQL with the extensions enabled, Spark will send those down to Cassandra which will then process them as it would if you gave them in CQL. And then another piece of sort of supporting documentation that I found is this explanation of the actual like optimization process called Pushdown Predicate. And it's responsible for actually doing the predicate pushdown. But it takes the query plan that Spark would originally come up with and sort of edits it when it detects that there is a predicate that follows those rules that were laid out and can be pushed down to the underlying database. And it works not just for Cassandra, but for JDBC data sources, for Parquet data sources, for Hive data sources, etc. All right, we going to go in. Oh, I forgot I included this. So these are some example query plans that were generated in a Spark Cassandra environment. Specifically, it's a DSE environment, but it's using the dot explain, specifically with the verbose tag. What's it called? Extended, set to true, so you can see the sort of process by which Spark edits and optimizes the query that it comes up with. So you can see, well, hopefully, I don't know if that's actually readable, but the first sort of parse logical plan section, it comes up with, this is just a simple statement where you are filtering on equality. So there's a single where clause or filter that's an equal sign for one column. And then underneath that, there is a relation, the Cassandra source relation, because it's going and getting that data from Cassandra. But you can see the original plan, because it goes bottom up, is to go get data from Cassandra and then filter it down so that the tenant UUID is the one that the UUID column is the one that we specified. And then it does some sort of analysis and optimization steps. And then in the end, you can see that there is a, still scans the Cassandra table down here, but what's actually happening is it has this push filters section where equal to the tenant, the UUID that we gave, and it's going to push that down to the Cassandra table. And then we also have one where this is sort of the same example. It's the exact same query, except that previously I have cached the like sort of full table scan version into Spark already. So you can see at the beginning, it's the exact same. In the sort of logical plan, that's the first step. It's exactly the same. It has the filter step at the top, and it has a Cassandra source relation. But then you can see as the optimization and as the physical plan is constructed, that it realizes that it has that data in memory. So rather than having that full Cassandra data source relation becoming an actual scan from the Cassandra table, we are actually reading the schema from the Cassandra table and then using our in-memory data frames, which were cached earlier, in order to pull that data, and then we're filtering on it. And then for our demo, we're actually going to look at a few more of these explanations. This is a good time for questions in the chat if people have any.
Do you know if this predicate pushdown is implemented in like other database connectors, like relational databases, or I don't know, like Hive? I guess Hive, it has to scan everything. Yeah, for other databases or things like Elasticsearch.
You mean from Spark or just
Yeah,
like
from Spark. Yeah.
I don't know for sure, but I would say probably because it's a sort of general optimization that can be applied to your query plan. So if it's sort of if it's possible for Spark to push to recognize predicates that are valid and push them down to the database. Yeah.
Okay.
All right. Got our Spark shell up. All right, so the first one we're going to look at, it uses, this is actually kind of an old method for using the Spark Cassandra connector. But if you look at the query, it says spark.read format org Apache Spark SQL Cassandra, and then option key space test, option table, give the table name, and then it just has .load. So there's no actual filtering here. There is nothing going on except it's generating a data frame from the Cassandra table. And if we wanted to explain, we can get Spark to show us the query plan in a way that it evolves over time as the optimizations are applied. And this one is extremely simple because, like I said, we are loading in data from Cassandra. So it's really just the Cassandra source relation is the only thing that really needs to be there. And if we were instead, maybe it's a good idea to actually look at some of the data.
How much data do you have in here?
It's, I want to say 10,000 rows, but it's just randomly generated data.
Gotcha.
All right. Yeah, a little bit limited on processing power, but you can see it's got a UUID row, a bunch of integer rows, a date row. TS is actually a time UUID, but I'm not sure if that actually shows up in Spark. And then we can see that sort of example one. In this case, we've got a where, and it's, whoops, I'll change the name of that column. And I'm also not sure this tenant, this UUID is actually going to show up because it's a random data set. Oh, I forgot to actually load this in as a normal variable. So that's just that same query from before. It's the full table because we're referencing it here, even though Cassandra does lazy evaluation. Oh, error. Oh, because I made that change before, but then didn't do it again. All right. And this time we see that same sort of thing where the filter at the top becomes a push down predicate. You can see pushed filter is equal to and the condition that we gave it. And you can also see what this does with some more complicated Spark SQL stuff. So Java method is a Spark SQL method that will apply a Java method of your choice that takes that specific kind of column as an argument, and it will generate you, it will apply it to each row. So it's a method of using, because I forgot to change the names, the row names again. Yeah, so Java method will apply your selected method to each row, the column that you give it. And you can see this one as well, loads data in. And then it has this top level where the selected Java method is being applied to that row. So specifically this time we're using Java util UUID from string, which forms a UUID object from a given string. So if you give it a string with full UUID in it, it will turn that into a Java UUID object. And that's sort of part of a process, because one of the tasks that I've had before is to turn a Cassandra time UUID column, or at least part of it, it came up during a work task to turn a Cassandra UUID column, which gets loaded as a normal UUID or string type into Spark. And in order to see what dates they're actually all associated with, what timestamps make up the timestamp section of the time UUID, you would have to convert it into a UUID object. So that's getting the string, turned it into a UUID, and then use the UUID timestamp functions in order to get the timestamp associated with it. And then if we were to look at what this sort of data set actually looks like, it'll show us that we're, in this case, the Java method and the reflect inside Spark SQL are essentially the same thing. But what it'll do is it'll create a UUID object from the string that it gets from the normal time UUID. And you can see that still in the logical plan at the top. And you can see sometimes it's split into project, the reflect, or Java method function. And then sometimes that it's portrayed as the individual function itself, what will be happening and what will the arguments be. And that is all I've got for today. If there are more questions about predicate pushdown or other things, it's a good time for that.
Awesome. Thanks, Obi. Yeah, this is a, I know this works, but it was a good explanation. And I really liked how you showed the explain. I think explaining the query plan is something that very few people get to in any database, let alone like Cassandra and Spark. So, you know, because Spark is such an instrumental tool in dealing with Cassandra, you know, and you're not using Spark because you're, you know, playing around with some inserts and updates. I mean, this is for massive operations. It's good to know how to optimize it. I mean, this is a massive improvement if you can push the predicate down, right? Like, why would you? And the other thing to also think about is, you know, maybe to show how the pushdowns can be leveraged in joins when we're doing like a star schema where you have a table and you have quote unquote, you know, foreign keys to other primary keys, and basically how that can be a very effective tool to use Cassandra as, well, data warehouse is a very big term, but like to store data in Cassandra and do joins fairly effectively with Spark without having to take it out of Cassandra and put it into like a Snowflake DB or a Redshift to do the same type of query. So awesome, very cool. Any other questions, folks? Great. Well, thanks again, Obi, for another amazing talk. And you know, next week, folks, we're talking about I think dbeaver again. We had talked about it on a data engineering lunch before. dbeaver with Cassandra, and always looking for new topics for what to cover next. We'll be here next week, same time, same place. Thanks, everybody. Have a wonderful week.
Thank you.
Thanks, Obi. Raul.